So good afternoon and welcome to today's presentation regarding Plant 3D and Advanced Steel. As I just previously said, my name is John Bennett and I work for Graitec in the UK as a customer success manager, and also I'm a technical consultant around advanced steel and other steel-based products. A couple of things today. There is a handout available in the window you should see on your screen for you to be able to download. That's a PDF of the PowerPoint that's being presented today. There should be a recording made available after the presentation, probably come out in the next couple of days. You'll probably get that through a marketing email. So with that, I'm going to sort of move on into the next slide. So a little bit about myself quickly. So I've been working with steel fabrication now most of my life, since I sort of left school really. I've worked in, got into CAD when it first sort of came around. That led me to working with steelwork and drawing in that sort of platform. I ran my own fabrication business for a while. I then came back into working for Graitec as an application engineer, primarily teaching and training and doing sales, pre-sales, post-sales, and then finally implementation. I also worked for Autodesk for a few years as part of their team under the Advanced Steel project as well. And that led me to integrate with some people that work in plant and engineering sectors in the North American region. So a couple of sort of intros for today. We have, this is one in a series of webinars that we're doing over the next sort of 5 or 6 weeks. My colleague Rob would have done one last week or earlier in this week, I think actually, for the Project Explorer and Advanced Steel. We'll see some other ones coming up over Navis work, steel and Revit integration as well, and a bit on housekeeping in your drawings, how to eliminate your errors and stuff. And we're doing one on modular workflows as well for modular buildings. Also, you can check out any recordings if you ask and send an email to marketing@graitec.com. They will send you some links. So a little bit about Graitec. Graitec is an Autodesk Platinum partner. It's based across the world probably now, is probably the best way to describe it from the top bit there. We're also a software developer, and we provide products in the analysis and detail and fabrication industry sector. And we do have a global presence now with a bunch of local experts based in many regional offices throughout the world. And our focus is obviously upon customer service. So we've been around for 30 plus years now. Our headquarters is based in France, and we've seen quite an extreme growth in the last couple of years, which has led to an expansion in the number of staff that we have now. When I first started, I think it was about 100 or so, and now we're sort of up to over 500 people, all are based in local regional offices, all experts in their region and also their products. And as I said, a lot of our products and also our software development products that we do for analysis, concrete detailing, rebar design, etc., through our power packs and things like that, get used on many, many projects throughout the world. So our primary product range or portfolio is, we obviously are an Autodesk Platinum reseller, as I said earlier on, and we cover the full range of Autodesk products available, including their architectural and industrial collections, product and design, manufacturing, etc. And also you can buy just a plain AutoCAD product if you so wish. And we complement those with our own Graitec products as well. For analysis, we have advanced design, and then we offer a series of platforms we call BIM designers, which are for additional tools that fit on top of Revit, for example, to provide rebar detailing. We also have our own MIS system as well, and then we do some additional bolt-ons, which we call a power pack for Revit and Advanced Steel, to complement those products. So we're going to come now into the main topic for today's conversation, which is the plant and Advanced Steel. So quite a few years ago, Autodesk purchased Advanced Steel, And through the form of the transfer file technology they have and the object enabler technology, this enabled us to have a closer working relationship with the Plant 3D environment. So today we're going to take a little look at that, and look at some of the background behind how what's called the SMLX file, which is basically a transfer file, is used. And also we're going to look at the use of object enablers between the two platforms to enable you to work collaboratively across those interfaces, and my personal take on how I would configure and set up a plant project to include advanced steel. So the advanced steel SMX file is actually a mechanism that basically transfers data from one file to the other, and this was incorporated into Plant 3D a few years ago, replacing the traditional SDNF file. And it uses a series of database entries and tables to map the sections from one platform to the other, effectively a transfer file which is based upon an XML format and a series of database entries in the background. It uses shape references, or it can use a direct one-to-one mapping reference as well. Its foundation comes from the use within the Revit Advanced Steel link. So a little bit behind that, it uses section mapping, which is based upon what they call expression rules. These are stored in the database tables in the background. They can be quite complicated, and basically they cover how the section is determined, and they map from one data source to the other, being that similar profiles have similar criteria in either of the parent platforms they reside in. So the mechanism in the background uses that technology to be able to transfer from one to the other. Primarily this data is stored in a database called the GTC profile conversion table. So sort of a bit more behind that now. The section mapping is based upon rules, and these rules actually refer to the object shape code. So if you look at the shape code in Plant 3D or Revit, for example, and you'll find a similar sort of shape code analysis available within Advanced Steel. And those references have common entries like the width of the flange, the thickness of the web, the root radius of the section, and possibly the slope angle, etc., the overall height of the profile. And what they can do is they use the formula at the top to minimize the entries that are required for a range of beam sizes. So depending on which country you're in, you obviously have IEPs in Europe, W sections in America, and we have UBs and UCs in the UK. So all those kind of things can be mapped just using their primary parameters from one platform to the other. And obviously you can have a designator being that that platform is Plant 3D or Advanced Steel. So also there is an option actually to create a one-to-one mapping. So sometimes people want to add stuff into the system, so they can create their own mapping references from one to the other. And also this did overcome some of the problems that was found in some of the Revit families, where there was just slight differences in the naming conventions between a lowercase x and uppercase x. Just little things like that would throw it out. So what they did is they created a one-to-one mapping, and this also allowed users to add it in, and it was obviously a lot simpler for people to understand rather than actually creating and trying to understand all the code and formulas required in the background. So most people, if they add anything in, tend to add this in via this format. And if you go take time to look, you'll see where it's adding the entries into the database in the background. So the other way to work with Advanced Steel and Plant is through the object enablers. The version types available, 17, 18 and 19 for both platforms. And the main thing is to make sure that you have the correct one installed for the version you're trying to work in. And this will allow you to work smoothly between the two platforms. So basically you can see the Plant model in Advanced Steel, and you can see the Advanced Steel model inside Plant itself as well. And There are certain limitations, but predominantly you can snap to it as well. You can work with it, and obviously you can turn it on and off depending on what you want to see. And it's done, you can work with X references with it, which is very common in the plant environment, that a lot of people do use X references within their plant projects to link the various aspects and sort of criteria of the project together. They don't just have one big model with everything in it. They'll split it out into concrete, equipment, and structure, for example, and even have sub elements of that. And then they'll link various models together to work out what they need to do to add the various elements in. And say the piper might work on one bit and the structural detailer will work on another bit. So I put a couple of hyperlinks in this, which should be available in the PDF. So if you click those, it should take you to a relative web page there at the bottom of the page there. So we're going to sort of take a look at trying to work with Advanced Steel and Plant 3D. We're going to just a little overview of either platform. You'll see the interface between the two, how it works, the basic tools that we use in each, and you'll see a lot of the similarities because they both come from an AutoCAD derivative. And obviously we're going to try and check how that works between the two and how you can coordinate. And hopefully I'll get around to showing a few little bits that I've sort of worked out myself along the way, and obviously adding a bit more detail to that. We probably won't have time to cover absolutely everything that I've worked out, and at the end of this presentation there is some links that will actually show you some additional videos and data that I've collated and added into the end for the users to work with. So I'm going to switch over to a live session, so to speak. I'm going to show you the two platforms individually and collaboratively as well. So first of all, I'm just going to click in here and I'm just going to come to my Advanced Steel platform. So for those of you not familiar, Advanced Steel is a derivative of AutoCAD and is now what they call a true vertical. So you can buy it on its own or as part of a collection from Autodesk. It comes with a version of AutoCAD as well. And a lot of the basic tools that you'll see within the system work exactly the same way. There's just obviously you want to draw a line, you can draw the line, you can type a command line, or you can use an icon to do it. And Advanced Steel predominantly has icons and tools up on the ribbon that you can use to create objects from. So for example, if you wanted to create a beam, you would do it very similarly to how you would probably do it in Plant 3D, and that you'd just set your ortho if you wanted. You can click a point in the model and then you can drag it out, and then it will give you a properties dialog box, and in there you're basically accessing a database where you can change to a range of sizes. This will obviously depend on which country you're in as well. So I'm actually running in the American version today, but there's a whole range of I-beams that come across from different parts of the world. So depending on which country you're in, you'll have a different version. You can obviously delete an object as well. You can create things like plates as well. So you can just drag it out like dragging a rectangle out. And it'll obviously bring in a size here. You can adjust it inside the dialog if you so wish in here, and it will change the size. And you have access to a materials library as well. You can come in here and there's a vast number of materials, and normally the system is preference depending on which region of the world you're in. You can set a coating and add coatings in there as well. There's certain elements where you can add weld points in. You can add a bolt group in as well if you so wish. And there's several different tools depending on which way you want to create a bolt group. There's obviously grids as well that can be added in. So fundamentally every single tool that you would need for detailing and modeling in steelwork. And on top of that, you'll then have what we call macros. Some people call them connections or joints. And everything here can be added. So this is probably a bracing joint here. It has some properties behind it which control it. So not only can you manually add the elements, you can also use a macro to place them and store entries and change these elements in here, and you basically populate the dialog box and it changes in real time. So it's quite a flexible program. It has elements for drawing staircases as well. This is a straight stair. This element here is actually a joint as well. It's actually part of the stair macro that's available. So I've used that to create this stair within this model. And within this model, you can see there is a plant reference object here. So this is the sort of the ladder vessel, I think it's called, inside the plant project I'm looking at. So it's residing quite comfortably and happily inside here, and it is actually installed as an X reference. So if I just type xref in here, those of you who use plant will be familiar with this kind of interface. So I've just loaded it into here, and obviously I can turn it on and off as I need to, as I require. So we can flip to the corresponding platform for this. So if I wanted to, I can close this project, close this drawing down in here. I can leave it open, but I'm just going to close it so we can see it's shut down. And then what I'm going to do here is I'm just going to flip across to my plant software. So my plant software here, I've come into what is a plant project. Now, people do set these up differently depending on what they're trying to do. So I've tried to show a basic sort of setup here. I'm obviously in the plant 3D part of it, the model part of it, and you can see the traditional type of elements here. So this is the ladder vessel that we were looking at just now. It's obviously residing inside the plant, and it's part of the project. And similarly, there's other elements like to do with the structural thing here. This drawing here is a steelwork for a pipe rack that's been created, and it's been created some basic steelwork inside Plant 3D. And this would normally then be sent to someone to continue to detail it if it was required. It might go out to a fabricator, or it might go to the structural detailer within the company. It depends on how the engineering system is set up to work within the practice. But one of the things that we're doing is obviously we're trying to incorporate the plant and the steel together using the advanced steel platform. So if you look here, this particular drawing here is actually it's actually an advanced steel drawing. I can tell that by just clicking on it here. If I bring up the properties of the elements, I can see that they're advanced steel objects. So although I can't do anything with it, I can see it inside Plant 3D. So this is courtesy of the object enabler, allows me to see that element within inside the plant project. So how did I get from it being here, which is obviously a plant model, to being obviously then transferred out to be this? So the way this works is inside Plant 3D, there is an option to do an export. It's called here Export to Advanced Steel XML. There used to be the SDNF, Steel Detail Neutral Name Format there, but now they replaced it with the XML one. So I'm just going to come back into my structure here. So how does this work? So you press this, obviously the interface here, and you can obviously go off and create a file. Now, personally, what I do is I actually create the file. I actually put it in a folder that's actually within inside the plant project itself, so that I can find it when I go to do this. So if we call it, just call it something today, so pipe rack. I'll just put today's date in it, just so I can hopefully find it again in a minute. So, and that will then take me back to the window. I need to then click on this button and select some objects. So I know that there's only the steel objects, and I put the crossing window around it. And then I press the export button, and you'll see a little progress bar down in the bottom right here of the screen. And this is now exporting the file that we're going to use to import into Advanced Steel. So the next part that I would do myself is I would create a folder within this for the discipline. So I consider the steel a discipline within the plant project, and I actually embed my advanced steel models under my plant project so that everything is stored within the structure that has been set for the plant project. So I've got a particular folder in here. Obviously you can have subfolders if you so wish. So here I've got a subfolder. Now what I did is I created the folder, and when I created the folder, The important thing was, because I know these are going to be advanced steel drawings, I've actually set it to use an advanced steel template. So that is actually, when I run the drawing, it will actually go to that particular template and start correctly from an advanced steel template. So what we do here is we would go new drawing, and I'm going to create a corresponding drawing to today. So if I call it pipe rack, and then I'm just going to put today's date on it again, 0319. I'm just going to put a little bit on the end so I know it's slightly different, and then I'll go OK. So we can see that appear within the plant project, and now I've obviously created that drawing here, and I can tell it's an advanced steel drawing because of the layer structure, because in advanced steel we use layers and we use objects are driven to particular layers depending on how you set up the system, but there is a fundamental layer usage in advanced steel. So without anything else, I'm actually going to close that file now, and I'm just now going to flip back to my advanced steel platform. Now, what I'm going to do now is open the same file inside Advanced Steel. So what I need to do is go and find the particular file. So in this case, I know it's in here. It will be under the plant models. It will be under this file in here. So it will be hidden away in here. So that's the file that I've just created today. So if I open that file, it will open inside the Advanced Steel platform. Now it has nothing in it because I didn't create anything. But what I can do is, using the Advanced Steel export import options here, I can import the SMLX file. So again, I click that, and then what I need to do is go and find where the SMLX file is stored. So what I would do is obviously map to the particular project. And obviously I have the SMLX files in here. And then I obviously need to go and find the one I've created today. So this is the one that I created today, and I would open that. Again, I get a progress bar. It just flipped up down the bottom. And now that has brought that in to Advanced Steel. And these are now Advanced Steel beams. So we're looking inside the database here, and the sections have been mapped and transferred across. So the detailer could now set about sort of breaking this down. You can see these beams run all the way along, etc. So that's probably not going to be acceptable to most people. So you would set about modeling in here and splitting it up, for example. So I'm just going to split it down a little bit in here. Just going to mainly at the main columns here. So I just pick some points. So you use the same snaps as you do in AutoCAD or Plant 3D, so like Node, etc. And now this will become a series of beams that have been separated. And then what we could do, so we can obviously then come in and we can use some of the connection tools. So I'm going to put a couple of basic connections on so that you get the idea for this. So this is a base plate connection that comes in for Advanced Steel. And what you can do then is you can put it on, and obviously you can edit the parameters in the dialog, but you can also do other kinds of things as well. So here you can select the joint box, and here we have a palette. This is an Advanced Steel palette, and we can use tools like this to actually copy the joint around. So you would press this, then press pick an element of the joint or the joint box, press return, and then put a crossing window around here and try and get all the bits that you need. So in this case, it's all the columns. So now I've put all those joints onto the bottom of the columns. And there's hundreds of different types of joints in here, to be perfectly honest, more than I can show you today. So I'm just picking a couple just to give you a demonstration of how we apply the joints. So rather than build all the elements individually, you use the joint macro to give you the elements that you need, and it accesses a combination of the database to look in here, and then it uses things like parameters, measurements, etc. to set out the various components in Advanced Steel. So what we can do now is we can save this file, and I'm now going to close that file in here. If I then pop back to my plant project, so I'm just going to come back into here. So remember that we created the file under here. This is the file that was created inside the plant project. And you can see now I've opened this inside Plant 3D, and you can see that the model has been transferred across, and you can see that I put the clip angle joint on there. I can see the components. Okay, I can't actually do anything with it, but I can see it now back in Plant 3D. So obviously this would probably have an X reference added in it to link it together, to show like piping. So maybe the piping was running along the rack, etc., and you might want to put some pipe supports in, or some shoes or clamps, U-bolts, etc. So the piper could continue to add his stuff in the piping model, and you bring the two together in a collaborative way. So that's one method to work with Advanced Steel, to actually create a file and then export the data out from the plant project. The other way that I do it also is to actually use the elements that are inside Advanced Steel and also inside plant. So here, this is the ladder vessel that we had open just now. So obviously this originally was obviously linked to a steel tower as well that came in and supported round here, and it showed the preliminary of a staircase. Now obviously with that, that's probably the two sort of go together, and the stair is fairly rudimentary in here. So obviously if I was using Advanced Steel, I probably want to make use of the stair macro to do this. I probably don't need all this steel because I'm probably going to end up having to move it. I just need to know where the primary steel probably is for the concrete bases, etc. And now it needs to work in with the tank on the side, etc., and any supporting cantilevered structure here. So rather than exporting this, I can work in it in a different way. So what I can do is, if I just shut down a couple of these in here. So just going to close that. So if I just then pop back to my Advanced Steel, so now I can come back into my Advanced Steel, and similarly I can open a model here. Now this is the model that was on the screen when we first started today. So this is actually an Advanced Steel model, and again this is embedded inside the plant project. So if I just flip back into here, you'll actually see the same drawing is actually here. It's actually under the plant project. So again, I went back here. Obviously, I created a new drawing which was set to go to an Advanced Steel template because I knew I was going to want to draw Advanced Steel objects in it. But what I also did is then I attached an X reference to it, where I attached there for the ladder vessel, and I probably attached one for the stair tower as well to give me the primary positions of where the steel went. And then what I've done is I've actually gone on and used that to create the stair. But obviously I didn't create the stair exactly the same as the way it was created in the other platform. So if we were to come back into here, obviously the way the stair tower is inside plant is different. So again, I'll just open that back up again in there. So in there, this layout and configuration has probably not come through how I would like it to. And so I've adjusted it. I've put some extra supports in between the two to make it work from one platform to the other. So I've used the draftsman's license, so to speak, to achieve what I need. And this is what you would do at a detail level. I've added in a series of connections, obviously to facilitate the bracing and the other floor joints, etc. I've then used a handrail joint as well to do what I need. I'm also going to obviously want to produce some drawings, etc. from this. And the other thing you probably want to do is sometimes we can look at other elements that are required. So like you can see, this is obviously a Plant 3D support object, a pipe support here. I've actually replicated this inside Advanced Steel because I might actually want to recreate that and make a new one, say, or actually fabricate it from something, or I might just want to order it. So inside Advanced Steel, you can actually take these plant objects that you see in there and export them back to be an ASYS solid. And then for a process inside Advanced Steel, we can turn that into a special part, we call it, and then we can insert it into a model. And then we can also give it some standard referencing and numbering as well. That's one way of doing it. Another way is to also combine that and make it back into individual elements. So in this is actually made of individual elements, and it's actually inserted into the model via a method that we call custom connection. And this gives us the ability to actually modify this as well, because I've built certain elements into this as just joints, etc., so we can change the way that it works. So to sort of, this is an aspect that I've done some more work on the videos at the end of the presentation. I've got some PowerPoint links that I created, but just to quickly show you how it sort of works. If you were to create a new file in Advanced Steel, if you come in here, obviously draw a beam somewhere. I like to know where I'm drawing my beam, so I tend to just give it a particular start point and a measurement. So this is how you position the steel. So I think you do a similar thing in plant as well. So with that in place, what we can do is inside Advanced Steel, you can create a solid object. So what we did here is there is what's called a pipe support here, and that is something that I've created initially, and then obviously you can see I've been testing this today, done several different things here. So how do we do that in Advanced Steel? So what I did was originally I took the pipe support from Plant 3D, and I, to be honest, exploded it back to be an individual element, so it became a 3D solid inside, and then I used that to actually bring it in to Advanced Steel. So at the moment, this is the pipe support that was there. It's a fairly basic solid object. Okay, I just made it at a particular insert point, which is very critical in the way you bring it into Advanced Steel. And then what you can do is you can actually bring that in as what we call an Advanced Steel special part. So if you click a reference point in the model, it can be anywhere you like. It doesn't have to be on the end of it. It comes up with a little warning dialog there. And if you sort of ignore that and then go back to where you need to go and find it from, so it will take you to the symbols folder in Advanced Steel, but you can store them elsewhere. You don't have to have them stored in there. In fact, I would probably recommend that you don't store them in there. So you should probably store them somewhere where you know where they are. And we can bring this in. We can set it up to have a particular material, etc., if we want in here as well. So you'd go under here, steel, come into here, set a particular grade. So as you can see, there's a huge database in here. It's, and under here, you would set a model role. This is all particular to Advanced Steel. One of the things, if you tick this, it will transpose that block name through into this element in here. And this can be used so that it appears in the bill of materials. So with that in place, that's now an Advanced Steel object, and I can actually move this and position it where I want. So if I midpoint here and go on to the node point on the end there, and obviously you can move it a measurement as well. So and the beauty of this is that you can actually interact with it as well, even though it's an ASYS solid, because now it's recognized as an Advanced Steel object. You can click certain elements, like here I'm just going to put some bolts in here, and I'm not only putting them in there, they're actually going through into the beam as well. So this can be useful if you need to make an attachment to it. One of the things you can do, obviously, also you can assign some numbering for it. So you need to make sure that it's got here. And I'm just going to apply that. I'm just going to run that. So in Advanced Steel, we give things numbering. So this is what it's called as a part mark. I am going to try something else. This sometimes doesn't work. Hopefully it should work. You can also have a standard reference for it as well. So, and you can apply that. So you can see that this has changed now. This is because I created a standard part file for it. So I'm saying it's a bought-in item. It's got a particular reference number, and I've given it something so that it stands out. This could be your product code, etc. So I think this fits quite well within plant as well, because these items tend to be bought-in items off the shelf from people, or stock items that are kept in a rack that people reuse time and time again. So I think that's quite a good approach to doing it. So similarly, you can actually combine that as well into so I can draw another beam here. And this is another tool that we have inside Advanced Steel, which can be quite a good little tool. We can insert what's called a custom connection. So this is the same special part, and I can just go in here, I can pick the supporting beam, and I can pick a reference point where I need it to go. So I don't have a particular point, but in this case, I can just put a point there. And what I've done there is I've actually combined it into a connection, so the bolts are actually inbuilt into it as well. So it's brought that all in as one item, and obviously the bolts are in there as well. And if I click this, I can actually edit that as well. I can get to the individual properties of any element now in here, and I could change them if I needed to. So this should have the same setup as the other one. So actually, if I now renumber the model, if I've done it correctly, it should pull through the numbering from the standard part template. So this can be quite useful, obviously, inside a plant project as well, because, for example, here we do have, obviously, we have a piece of pipe going along here. We do have it on a supporting beam here, and obviously it's drawn as a plant element, but you might want to get that into Advanced Steel to obviously put some holes in the beams that are supporting it. So you would repeat the same process that I've done. Now, say that the component wasn't exactly the same, you could use a custom connection built out of elements, and this can become variable then as well. So this particular one here is actually a custom connection that I can alter, etc. if I need to. I can insert a new one over here. So I know the pipe bends around, it probably won't fit on here, but I'm just going to bring it in anyway and just show you this, how it works. So sometimes it's a bit easier to see in wireframe. So here I'm going to insert a custom connection again. So I'm going to do the pipe support again with a special part, which you just saw me do. I'm going to pick the beam. To be honest, I'm going to put it on the end here, and we're going to see it come in, and it's obviously going to come in the wrong place. We know it's in the wrong place. I'm going to tick allow modification. Now, what I can do is actually it has a node point where it comes in, and I can pick this up and I can drag it. And similar to plant, we have some snap filters as well here. So I can go and pick a point here, and I can move it along. So at least I can align it. And you'll see that it's actually putting the holes into the beams as well. So the holes are now in the beam. So the whole element moved along. So that's one way to bring it in. So to delete it, you just select it and remove it. So that was one variation. I can do the same thing here with the other pipe support that I created here. So I can do exactly the same thing. I can pick the main supporting beam. I can pick a reference point to bring it in. It might not be where I need it to be. And again, I can pick the reference node here and select it to drag it. Come here, use my snap filter again, and I'm picking the center of the pipe just to move it across. And we can see the bolts moving, okay, inside here. So I'm just going to put that back into a conceptual mode. I'm just going to click the save button in a minute. So one of the things is this is actually a joint built inside the custom connection as well. So if I come in here, you can see the plate thickness is 3/4. But if I wanted it to be 1 inch, and if you watch carefully, you'll see the plate will change. So I can adjust this. I can actually adjust how this works inside the system. I can even adjust the number of bolts, etc., that are required. So you would come under the parameters here, and you can change how this works. So there are horizontal bolts each side. So at the moment it's got 2 per side. If you wanted 1, you would change it and it would adjust. So not only did I bring it in as a custom component, custom connection, I've brought it into the model and I've adjusted it to something I need to do. So that gives you an alternative if you don't want to bring it in as a standard part that you'd always use, but more like a standard configuration that you would use, but then it would be adjusted to what you need. So if we just save that file, and then obviously we can close that down. And if we were to flip back to the plant project in here, if we come back in here, the same file is obviously inside the plant project as well. So I can open the same file inside Plant 3D, and you can see the element that I just added in. I can still select it, I can still look at its properties, etc. Obviously I can't do anything with it because it's an advanced steel file, but the point is I can interact with it between the two. So this is where you have the discipline of the piper and the discipline of the steelwork detail working together and collaborating. Similarly, obviously, it is possible to create drawings as well within each element. I will just try and remember how to do that. I'm not. So we would go in and obviously press that to create a new drawing. So I'm just going to click into the orthographic tab here. Obviously, I'm going to click into this folder here, and I'm going to go new drawing. I'm just going to call it web test 290319 just for today. I'm not using any special templates here. I'm just going to go and use the normal sort of default that's available. So what you can do is you can obviously select the files that you want to add into this drawing as well if you want, add the views on, etc. So this is, so here I'm just going to go and edit view. Would that not do what it's, okay, let me do it this way. This is the way I did it the other day. I knew this would happen today. So I just need to obviously pick the right view that I want. So I'm going to go into here. That's it. So depending on what you want to do, you can go in, obviously change the view, how it works, what it's looking at, what element is here. I'll just set it back to that. I will be honest, because I'm conscious of time, I'm just running out of time, so I'm just going to create that. So obviously that, depending on the scale you want as well, so obviously we can edit the view as well. So I just wanted to show that you can show a combined model using the advanced steel elements actually back inside the plant model as well. So you can continue to do your normal sort of drawing processes in there that you would do for plant. I will be honest, I'm not a plant expert, so I don't understand all the capabilities of producing the drawings here. But obviously you can add other elements as well in here as well. But that's just the advanced steel model at the moment. but you could attach the other element in there to combine it all together. So I think you'll see some. I was doing something earlier on today. That was the pipe rack. I've obviously done other ones in the past. I think this was the one from the previous webinar I did, where I showed the combination of steel and plant objects in the same format. So similarly, if we come back to Advanced Steel, I will just come back in here. I'm just going to make sure that I've got this file closed, because like most things, it doesn't like being open in both platforms. And I'm just going to come back into here, and I'm just going to open that file again. I'm going to come back into the same file inside Advanced Steel. So the thing with Advanced Steel is you can obviously create drawings as well, depending on what you want to do. There is obviously a series of drawing processes available. I'm going to create a 3D view here. It should go on to drawing 310. I probably just need to do this. Actually, there's a slight glitch, I think, that if I remember correctly. Probably need to detach. I think there's a slight glitch at the moment in this version I'm using. I'm just going to reattach that. Okay, let's just try and run that again. Sorry about that. So it might take a few seconds, just to probably a few minutes, hopefully not a few minutes, but it shouldn't take too long to actually create this this one drawing. So that's drawing 310 it's created. So you should camera detail. So I've done the similar sort of thing with obviously the Advanced Steel environment. I've got the same sort of drawing, get slightly better detail probably because of my setup in Advanced Steel for the actual steel drawing. Not quite as good for the plant object, but I can again show it and I can determine how it's shown. So my recommendation is probably do your steel drawings in Advanced Steel and your plant drawings in plant to get what you need. The next step on from this is obviously with Advanced Steel, you can obviously do elements, part drawings. So if you require a part drawing, you can actually click this here and use a similar sort of thing to create a part drawing. And in here, if you go here, you'll see the part detail. So the details have been added in there. You can do them on multiple sheets or single sheets, depending on your preference. I know different parts of the world do different things. UK, we tend to do it on a single sheet. So America, they tend to put them all on one sheet. Similarly, I think I might have actually run this as well already, maybe not. So you can do a column drawing. So for an assembly, I'd probably do a selected one. Again, I'll probably just put it on a particular sheet that we want. So I'll just do that one there. Should put it on there. I think selected assembly each. And once that's in place, you can then show the assembly detail. So the preference of the product is obviously to produce your drawings for your project in Advanced Steel. Okay, so that is sort of a very quick overview of how both platforms work, how they integrate together and how they work together. With a little bit of setup and customization, you can actually achieve what you need. So I'm just going to now flip back to my PowerPoint. Just going to come back into that there. So we're sort of coming towards the end of today. I'm just going to sort of flip up here to the next slide. If there's a lot to cover, so if anybody has any questions, it's probably, you can email me at Graitec. My Graitec email address is there. It is also in the PDF handout. So if you want to reach out and ask any questions about stuff, we're quite obviously we're providing different services, etc., and I can respond to a few questions. So we obviously we have sort of services we offer through myself and my colleagues where we do sort of implementation and customization for people, and we sort of have a roadmap now that we try and guide people through how they should start off with using Advanced Steel and how we should implement it, looking at their aspects, right through to actually fully customization and deployment at the end. There's some video links here, etc. in here, so you should see that in the PDF that we've got, and they're all hyperlinks, so you should be able to click on them and they should send you off to some videos. Some of the stuff today I showed, I've done a bit more in depth on that. So, and one of those is actually to a presentation that my colleague did last month, which is on customization for Plant 3D. So that sort of brings to sort of close today's presentation regarding Plant and Advanced Steel. We've got a few minutes left towards the end of that. I'm not sure if anybody popped any questions in there. So yeah, okay. So please feel free to reach out. Obviously, it's quite a big topic and quite a big subject to cover in even an hour. So I tried to give you a good flavour of what to do with it. Hopefully you'll look forward and be able to use Advanced Steel and Plant 3D together. And if you need any help and assistance, if you just reach out to the Graitec team, they'll be here to help you. So I'll just hold the window for a few minutes in case anybody wants to ask any questions. You can use the questions dialog through your interface to do that. I'm just looking at that. Yes, I am recording it. Someone asked, so it should go out in a couple of days. It'll probably be on Monday. So someone asked, how is better to decide which way to go, AS-based project or plant-based project? If I was working with the two of them, from my experience in working with the companies in the US that I worked with, we always ended up embedding the Advanced Steel project under the plant project because the steel was a subordinate to the plant project itself. In other words, it was a discipline within that overall project. They would have a piping and equipment section, electrical section, possibly concrete section, and then steel section. Plus, we also found that stopped people copying the model inadvertently by actually starting it from Plant 3D. So it was just a case of configuring the project to start off with, putting in the various files, and then that would enable the people to work or open that file, even though it was in the actual file structure of the plant project at a Windows level. You could see it. What we found was people didn't do that, and then they tried copying it in and they were duplicating the file. So hopefully that has helped. Thank you very much for your time today. Have a good weekend. Please reach out if you need any more. Thank you very much.